All right, we're looking at Aleks, lesson 1, 2, number 4. And so we're finding the domain and range from the graph of a continuous function. Now, continuous just means it's not broken within the graph. So from the start to the finish, there's no breaks. As you look at this line, this graph, you'll see that there is no breaks whatsoever in there. And so we're going to try to find the domain and range. And it says use interval notation. That means parentheses and brackets. So when I find domain, I think of using trash compactor technique, where we try to smash everything to the x-axis. And so that's what I'm going to do first here, is imagine that this whole graph is like a garbage bin. And the graph itself is the trash. The garbage bin, we're going to smash it to try to make as much room as possible by smashing all the trash to the middle. And for domain, it would be the middle is the x. So I want to smash everything to the x-axis, which means this point right here gets smashed straight up. This open dot gets smashed straight down. Since they're connected with a solid curve, when it gets smashed, it's just going to become a solid line. So this graph right here, this is the true graph of G. This is the graph of G here. What I now have graphed there in red is G's domain. That is G's domain. G's domain is shown. That's what that is right there.
Right.
And so for domain, you're looking at the smallest x to largest x. So I start with this value here. It's a -3. I'll move that so you can see it a little easier. It's a -3. So question for domain, if it's a solid dot, would it be a parenthesis or a bracket? Bracket, you got it. And truthfully, it's the same on range too.
All right.
So solid dot's always a bracket. And over here, we have an open circle on 5. So is that a bracket or parenthesis?
A parentheses?
That's
Mr.
right.
Bill, right there it's a parentheses, but it's not infinity. What is the difference? Because I know
Okay.
infinities also have parentheses, right?
That's a great question. So if it did go on forever, you would use an infinity, represent like this graph extends forever. But the reason infinity gets a parenthesis is because since that's not a real number, that's not a real value, it's just like an idea.
Oh.
It means it represents going on forever. If you're
Okay.
talking money, you can't have infinite money. You could have $1,000, you could have $1 million, you might have $1 billion, but you don't have infinite money. And so since it's not a real number, you can never be equal to it, so it's a parenthesis. And the open circle means you're not actually there. In terms of money, it's like you have your $4.99. If you were supposed to graph what you have in your bank account and you have $4.99, you might be like, well, I don't know where $4.99 is, so I'm just going to kind of approximate it and just do an open circle on 5. Well, that would be acceptable. It's not, I mean, it's not perfect, but that's acceptable.
Yeah. Okay.
That's the idea. So that's why that's a parentheses. It's you're not exactly at 5. And so now let's look at range. And so I'm going to erase this. G's domain is going to go away. And now we're going to look at the range. And so what's different on range is you smash everything to the y-axis. And so as I smash this in, if I can, try again. It's not really cooperating with me. I smash into the y-axis. That's the visual I want you to think of here. I smash in this way. Let's see. The range, this spot gets smashed straight to the y-axis, closed dot. This open dot gets smashed straight over. Since it's connected by a solid curve, when it gets smashed, it becomes a solid line. That graph in green is now G's range. So that's the green is not the actual graph of G. This is G itself, but this is its range right there. And so you go smallest to greatest, or in the case of range, lowest to highest. So we start with the -2, and we will go up to this 4 value. The -2 will be a bracket or parenthesis.
A bracket?
That's right. And the open circle?
Parentheses?
Parentheses. And that's how you get your answer there.
Okay. Yeah, that makes